Good afternoon. Welcome to this course of Artificial Intelligence and Machine Learning. This is the starting class, the introductory class to our course. In here, we will be learning about fundamentals of artificial intelligence, introduction to machine learning, AI project lifecycle. Now, these things, that is AI and ML, are a really new trend into our industry right now. You might have used tools like ChatGPT, Gemini, Midsummer, etc. Here's the thing. We are seeing these tools for the last 5 or 6 years, but AI and ML is really old. It is here since the age of 1960s. Yes, you heard me right. And now what are we seeing is the fruit of the efforts that we have did 50 or 60 years ago. Now, you might be asking me, sir, why do we need to take this course? I mean, there is ChatGPT now, Gemini, and Midjourney tools. They can do all the work that is done by a normal human being. Yes, it can do work, but it has to be programmed in a way that it is able to do those works. And this is what I'm going to teach you in this course. This is a comprehensive course and an introductory course to AI and ML. Here, from the beginner level, you will get to an advanced stage where you will be able to build your own ML models that are giving predictions on the basis of some inputs. So let us start. Fundamentals of AI, that is artificial intelligence. Intelligence is no longer a topic confined to research labs and science fiction. It is inside the phone in your pocket, the website that recommends your next purchase, the bank system that flags a fraudulent transaction in milliseconds, and the hospital software that assists doctors in reading medical scans. Now you might be wondering to yourself, yes, sir, we had tools, that is, we had people before this that were able to do this exact task. That is, they were able to flag a fraudulent transaction, or they were able to guess based on your previous recommendations what should be recommended to you. Then why are we talking about artificial intelligence? The main advantage of artificial intelligence over normal humans or over normal computers is speed. While a normal human would take around 2 to 3 seconds to guess that what product will you purchase next, a same AI model will take milliseconds. Also, a normal human has a capacity to which it can take information, but an AI doesn't. AI can take millions of megabytes of data and can give you output, and that too with 100% accuracy. Now, note my words, 100% accuracy. You might be wondering that, sir, this is not possible, right? Every time? And yes, that is the case. Every time we do not reach for 100% accuracy. But in real world scenarios, 99 or 98% accuracy is also good. And having 100% accuracy can be a very strong indicator that you have trained your model in the wrong way. We will be learning about this in the further classes. This particular module builds the foundation that every subsequent module in this course depends upon. You will understand what artificial intelligence actually is. Now, in this era that we are living right now, you might have heard of many words: AI, machine learning, deep learning. I'll just highlight them for you. These are the four words that you keep on listening whenever you hear conversations about AI. That is artificial intelligence, machine learning, deep learning, and data science. And there should be a question coming to your mind that, so what is the difference between these four? I mean, whenever I see it from the outside, these four seem the same. That is, machine learning is also about machines giving output, that is, predicting outputs. AI is also same. Data science also seems like the same thing. So, three things you will be able to do by the end of this module. Explain AI, ML, and deep learning clearly and tell them apart with confidence. That is, from now, if anyone would ask you that, tell me what is the difference between AI, ML, and deep learning, you will be able to do so after this model. Second, give real world examples of AI in business across multiple industries. And why should you know this? Because in future, whenever you are trying to build any projects regarding AI or any project for that matter, you should always build those projects that are able to help in a particular industry. I mean, let's say, for example, you build a placement predictor and it is not used anywhere in the industry. What message does this send to your recruiter? The message is that you don't know what industry requires right now, and that is instant rejection. So, I'll be giving you real world examples of how AI is used in businesses across multiple industries. Describe the five phases of an AI product lifecycle and what happens in each one. So, if you would have heard about the software development lifecycle, there is also an AI project lifecycle. That is, what phases an AI project goes through before being deployed in the industry. And I'll be explaining you the each phase of it. So let us start. Fundamentals of AI. The most primary question. What is AI? Artificial intelligence is the science of building computer systems that can perform tasks which, when performed by a human, would require intelligence, such as understanding language, recognizing patterns, making decisions, and learning from experience. Now, these are really, some English words that I have thrown upon. I have taken the definition from the Wikipedia itself. And you will be thinking that, sir, whatever you said, it is just, some corporate speak language. The science of building computer system or performed by task when performed by a human. We aren't understanding what are you actually trying to say. So let us first dissect this line by line. What does artificial mean? First, let us understand that. You might have heard this term multiple times that this item is artificial or the fruits that we are eating artificial and things like that. So, what does this mean? The word artificial. Artificial simply means man made, or in simpler terms, if I want to say, artificial will simply mean a substance that we can't derive from the nature itself. Let's say, for example, there is vegetable, there are fruits, you can derive it from nature, right? But artificial, let's say for example, nylon. The nylon, I would guess, is the first example of any man-made material you might have heard about. Nylon is a man-made material. It isn't derived from any substance that is present in the nature. Yes, you may argue that, sir, the fundamental building components of nylon are derived from nature. And you are right. In the same way, if you talk about computers, computers' main feature, that is the processes that are running these computers right now, they are made from silicon that is derived from nature. But at the end of the day, it is man-made because it is not directly derived from nature. We take some things from nature, we apply our processing, and we make some things out of it. So, put them together, AI is man-made intelligence built into machines. So now you have got a slight idea that okay, AI is something artificial that we make. That is we man makes. That is people. Us people are making this intelligence, right? The next question that should come to you is what intelligence is. Okay, so why am I saying this and why am I really emphasizing on this fact is from a beginner's perspective, a computer is also an artificial intelligence tool. And why am I saying that? Let's say for example in computer you turn on the read aloud mode. What would it do? It would read the text that is present on your screen and it would read it in a loud manner. That is, let's say for example, this artificial intelligence is the science of building computer systems. It will start reading it word by word. Now for a beginner he would be like, sir, this is also artificial intelligence. And then you will ask why? Because this task was used to be performed by humans. It is requiring some intelligence. I mean, I have to have some intelligence to read artificial, the word of it. If you don't know English, you can't read the word, right? So you would say that, so it is having that intelligence and it is reading aloud. So it is artificial intelligence, right? Well, that's wrong. So, whenever we say a machine is intelligent, we mean it can do one or more of the following. Now, listen carefully to these four points. Perceive. Take information from the world. And what do we mean by perceive? Perceive, a simple example for a man, I would say, is a man or a woman, sorry. For a person, I would say, is eyes. Your eyes can take information around yourself. That is, it can take information about images, about text, about sound, about numbers, etc. Second is reason. The information that is taken by perceiving, it can process that information to reach a conclusion. And what do I mean by that is, let's say for example, I tell a machine that whenever an input is something, you do this work or else you do this work. Now, see carefully. What is this machine doing? It is perceiving an input. Then it is reasoning that whether if this condition is true, that is, if it is yes, then go through this path. And if it is no, then go through that path. Can you understand this? This is what is called as reasoning. This is what is called as reasoning. It can reason exactly that according to some input, I'll give the answer as yes or I'll give the answer as no. Now, many of you that are coming to this course would have learned a programming language that is Python, C, C++, Java, C Sharp. Can you recognize this pattern somewhere? I'll give you a second or so. Yes, these are the patterns that are visible in the decision structures or the control structure that we use. That is, if, else loops, or the switch cases that we use. And that is why the computers or the programming language that we use have said to have artificial intelligence. That is, they have some intelligence that was made by us, that was man made, and it is built into these machines. So, what is perceiving? Taking input. What is reason? Processing that information and concretely deciding whether to go through some this path or to go from this path. The third is learn, improve its performance over time through experience. And this is what we humans do, right? Whenever we want to learn something, that is, let's say, for example, you want to learn about Python or you want to learn about artificial intelligence that we are doing right now. What you will do is you will keep on learning, you will keep on taking new knowledge, improving your knowledge, and after some particular point of time, when you first started out learning AI/ML, and after let's say 5 or 6 months, when you see yourself, you will see a drastic improvement, and that is what should be imitated by this machine. Act. And one more thing, this learned aspect isn't there in Python programming languages, right? These decision structures, however time you pass the input, after let's say 5,000 input 2, it would perform the same. And that is why it is not true artificial intelligence. Fourth is act. Take an action or produce an output based on what it learned. Okay. So this is some tips. I mean, these are some tips. You can also go through them. Now let's move on. I add these tips because whenever I'm teaching, I do not want to miss anything. I do not want to miss passing some knowledge to you. That's why I add this so as to remember that yes, I'll also pass this knowledge to you all. So, evolution of AI. Let us first go through a brief evolution. AI did not appear overnight. As I said to you, AI is famous in the last or the past 5, 6 years, right? But it is a 70-year history of breakthroughs, failures, massive investment, and periods of disappointment called AI winters. So, what is this term AI winters? There were some periods, let us say for 2 to 3 years, that there were no new development going in the AI world. And these were called as AI winters. In these aspects, in these kinds of period, some people declared that now AI is over and intelligence can only be used by humans. But now here we are, multi-billion dollar companies built on artificial intelligence. So let us go to through the timeline once. You can go through this. Alan Turing proposes a Turing test. Can a machine fool a human into thinking it is human? The field of AI is formally born. And this is where AI actually began. And I would say we would attribute much of our success in terms of artificial intelligence as well as in terms of computers in whole to Alan Turing. Alan Turing is a visionary. He built the fundamental automata theory that we say that are used to build hardware for this computer was built by Alan Turing. So yes, the field of AI is formally born here. 1960s to 70s, early rule-based program. So research, the funding was very high, and it was a coded thing. So as I said, this if-else structure, it was similar to that. You can go through this one. The key insight is the reason AI has exploded since 2010 is not what we suddenly discovered smarter algorithms. Okay, so since 2010, as you saw TensorFlow came, PyTorch came, Scikit-learn was already there. So this boom in industry didn't come from some novel algorithms. The algorithms, as I'll be teaching you also, these are the same algorithms. 50, 60 years ago, scientists have derived them. We are using the same algorithms. Then what is the development that has happened? The three ingredients that were missing for decades finally came together. Number one is massive data sets. And I want to extremely stress on this point is because any intelligence you want to build, let's say for example, we want to build this intelligence into humans ourselves, okay? You want to learn something. You have to have some prior knowledge that is already available on the internet, right? Let's say, for example, I tell you to learn AI and there is no information available on the internet. Will you be able to learn? Absolutely no. That is what is required in artificial intelligence too. Artificial intelligence requires massive data sets. That is examples of this learning already available on the internet. Second is affordable computing power. Artificial intelligence actually used to learn on CPU only, that is central processing units. What the central processing units were to do is they used to perform mathematical computations because at the end of the day, artificial intelligence is maths. And I'll be teaching you also probabilities, statistics, mean, median. The artificial intelligence is just these operations working on a very large scale. Previously, central processing units weren't optimized to do this stuff. That is, they can do this. Okay, so let's say, for example, I give it 100 vectors and tell it to remove the median of it. Yes, it can do that, but it will take around 1 to 2 minutes. Whereas, if you give it to a GPU, that is a graphical processing unit, it will take around 10 to 20 seconds. It has 50 to 100x better performance in the cases of computation only. So, you should understand this really well. GPUs are optimized for a certain task, and that is running computations on vectors. That is really essential for building AI system. It can't do other tasks that CPU can do. That is CPU scheduling and other things that is required for running a computer. That is why it is said that a computer can't be running merely or solely on the basis of a GPU. It always requires a CPU and better neural network architectures. Remove any one of these three and AI revolution does not happen. And I will be teaching you what is this neural network architecture. Let us go ahead now. AI versus human intelligence. This is one of the most misunderstood comparisons in technology. AI and human intelligence are not the same thing, do not work the same way, and are not competing for the same space, at least not yet. So many people right now on the internet too, or on Reddit threads, you might be seeing that AI has reached human intelligence. Now humans don't need to do any work, only AI will be there and it will do every other task that we were been doing for the past, let's say, hundreds or thousands of years. Well, this is not the case, and I will show you in the next slide. Speed. Slow for large calculations, AI can do millions of operations per second. I started with this example only that any task that is done by humans in, let's say, for an hour or so, AI can do it in mere seconds. What is the scale? Human intelligence is limited by memory and attention, and AI can process billions of data points. Consistency. Human intelligence is affected by emotion, fatigue, and bias, while AI will give consistent output on the same input. That is, AI is somewhat deterministic. Common sense. We have a really strong common sense. That is, we understand context deeply. AI has weak common sense. And what do I mean by this? Is, let's say, for example, I need this is I write two sentences in here. This is one sentence. He is a smart boy. And I'll be writing another sentence. So let us read the first sentence. He is a smart boy. Okay. From the first sentence, what are you getting an idea? That the person or the boy that we are talking about is really smart and it is a positive affirmation. That is, it is positive, right? Now, come to the second sentence. He acts smart. Now, tell me, is that a positive affirmation or a negative affirmation? Well, it is negative. What we are trying to convey is he is acting like a smart person or he is acting egoistically, right? So, this is negative. Now, for us humans, it is really simple to identify this. Why? Because we are able to understand context. We are able to understand that yes, smart appears after acts and acts appears after he. So what this sentence as a whole means is that yes, this person is behaving egoistically. But for an AI system, these two sentences will be the same thing. That is, it will watch. Okay, so it is talking about being smart. So these both are positive affirmations. Now, obviously, right now AI systems have evolved beyond this simple example and they are able to identify the difference between these two. But take this as an example and see that AI systems can't, understand complex information because they do not understand the context in the same way as we humans do. And that is a really, in some manner, transformer architecture that is right now running ChatGPT solves this problem, but it has not solved it completely. Someone might have used AI in the day-to-day life. They would understand what do I mean by that. Let's say, for example, a coding perspective, I'll give this example. Some industries or some companies have a certain way of coding things, right? They might be wrong. They might not be the most efficient way, but they code in the same way. Now, whenever you run AI on those codes, it will fail. Why? Because according to it, it is only built on or it is only trained on the best data and it will struggle on that company's code base. That is what we mean by context. Creativity. Human intelligence creativity is genuine. It generates truly new ideas. AI is generative, but recombinational, not truly original. So, whatever new ideas that AI generates, it is only basis on the input that it has been fed over the years. It can't generate any magically new information out of it. Learning speed. Human intelligence is really slow as compared to AI. That is an acceptable fact. Adaptability. And this is where humans and AI actually differ from each other. Adaptability of humans is very high, whereas for AI it's really low. What do I mean by it? Let's say, for example, in the defense industry, AI is deployed, that is, artificial intelligence is deployed, and we have decided that AI is the best thing. We do not need humans, and everything that is deployed on the defense lines is AI only, that is, artificial intelligence only. Now, what happens is, let's say, for example, the situation changed rapidly. That let's say, for example, country A has attacked country B, and artificial intelligence is deployed on the front lines. Now, there might be a scenario that country A had by mistakenly or due to some malfunction this attack has happened. But you have trained your artificial intelligence in such a way is that whenever an attack happens on us, you have to attack back. That is, you have to respond back. Now, if a human would have been deployed in this place, he would have understand the context of the events. He would have understand that yes, malfunctioning has happened on the other side, and this was a genuine mistake that has happened. But autonomous AI systems will suffer here, and that is why we say that in terms of context and adaptability, AI is really far behind the humans. Energy. This comparison shouldn't be done actually because human intelligence energy use is really low while AI is really high. But on the same place, I'll say that the scale that both are operating on are really different. So students often think that AI thinks the way human think, with understanding, emotions, and consciousness. It does not. AI is pattern recognition at enormous scale, and I'll be teaching you this. That is, whenever you see ChatGPT or you see Claude, any AI system is just a game of probability. It is just determining the probability of a particular output on the basis of a particular input. What do I mean by this? Let's say, for example, I give an output of smart. AI is just predicting. AI is saying, okay, 70% of the time humans write boy after it, or 30% of time humans do this. And what will it do? It will go through the most probable path. That is, it will go through this path and output this. And why is that the case? And why do we think that AI performs the best 99% of the time is AI is fed on human data and AI will imitate what humans are doing. So it will only choose the most probable path and go towards that output. And we think, okay, AI is always predicting the same thing. That is, AI is always predicting the correct thing. But the thing is, AI is doing or imitating what we were doing for the past 10 or 15 years because that is the data that is fed to AI. Any new information, any new creativity, any new adaptability is where AI will really struggle. So let us now go through different types of AI. First is the weak AI, narrow or weak AI, an AI system designed and trained to perform one specific task and only that task. It can be superhuman at that task, but completely useless for anything else. What is the example? I'll just show you this. There was a famous game called as Akinator. This game was released around in 2007, if you could see that, right? What was this Akinator is? Akinator used to ask you a bunch of questions. You'll answer them and used to predict what actually is your superstar or the person that you're thinking of. And at that time, we used to think, oh my God, Akinator is a magician, that it is, reading our minds. Whereas it was an example of narrow AI. That is, Akinator was trained on a subset of data. It was told to perform one specific task, that is, predict the Superman's or superhero or an actress's name. And that is what it is doing completely well. That is, it is a superhuman at that task. Let's say, for example, in the way I asked to ChatGPT, if I ask this, that give me 5 examples of tourist places around, Africa or something that it will fail at that task. Why? Because it's a narrow AI. It has been performed. It has been trained to do this particular task. और तो होना है ना? Now, now, the second is general AI. An AI system with human level intelligence across all domains, able to learn any intellectual task a human can, reason about it, and apply knowledge from one domain to solve problems in another. This is what we call a human in a form of a machine. And this is what AI companies have been trying to achieve in the past hundreds of years. That is, they want to build an AI system that is performing exactly like a human being. And that is where AI systems are failing. ChatGPT, you might be saying, is a general AI, sir, because whatever questions we ask to it, it answers it immediately. Now, a large language model, that is what we call ChatGPT, can discuss many topics because it was trained on text about many topics. Understand this. ChatGPT was trained about multiple topics. It was trained about sports, travel, tourism, geopolitics, everything. And that's why it can output about those topics. But it does not understand any of them. As we humans understand whatever information we perceive. It has no persistent memory. This is somewhat untrue. AI has persistent memory, but the thing is that is not native to AI models. We design some architectures around it to give that persistent memory. It has no goals, no self-awareness, and no ability to take physical action in the world. It is still a very sophisticated pattern matching system. Exceptional narrow AI, not generally. Third is super AI, an hypothetical AI that surpasses human intelligence in every dimension. I mean, this is a really theoretical concept. It hasn't been tried anywhere, and it will take, thousands of years to reach to this stage. Now, let us understand application of AI in the industry. AI is applied in multiple industries. So you can go through all of these examples that medical imaging or drug discovery, in finance and banking, how is it used, or in retail and commerce. I mean, I encourage you to go through these examples because these are some examples that you should go through yourself. Okay. Now, introduction to machine learning. And I just wanted to show you a diagram. Before going through what is machine learning specifically, I want you to show you this diagram. Artificial intelligence, machine learning, and deep learning. And what exactly is this? Artificial intelligence is a really big field. It will include everything. That is, today's chat GPT that you are seeing is also an artificial intelligence. The programming languages, the if-else structure that we see is also artificial intelligence. Everything that can imitate or that can reason is artificial intelligence. Now, machine learning is a subset of artificial intelligence. And what do I mean by subset? Every tool that is called artificial intelligence can't be called machine learning. But every tool that is designated under machine learning can be called as artificial intelligence, right? So let us go through that. Machine learning is a subset of AI that gives computer systems the ability to learn from data and improve their performance on a task without being explicitly programmed with rules for that task. And what do I mean by that? Let's say, for example, I am building a fraud detection system. Now, for building a fraud detection system, what you actually need is for building a fraud detection system, you actually need multiple things. But great. So, when we are building this, so detection system. So this is what we are trying to build, right? Now, oh, simple ML pipeline is what you do is you first take data. That is, you first want this data. Then, after collecting that data, you feed it to a machine. And this is what is machine learning. What you say is, let's say for example, in data there are five columns, okay? That is, let's say this is a table. In this data, we have that whether this transaction was above 50,000 or this transaction happened at midnight, something, something. And then there is an output. That is, this is what we call a supervised learning. I'll explain the difference between these two. Now, understand this. We have also been given the outputs. It is said that, okay, whenever these type of transactions happen, it was detected as a fraud. That is, it was yes. Now we give that to machine. Machine will go through this input and go through this output, and it will try to learn. It will try to see, okay, for these type of transactions, the output is yes, and for these type of transactions, the output is no. Now, let's say after performing all of this, the accuracy of our model comes out to be 95%. That is, it is right for 95% of the time and it is wrong for 5% of the time. Now we deploy the system. That is, we deploy the system in the real world case. Now it is detecting a fraud and it is performing some wrong operations also. Now, and ML is such a tool that whenever it is deployed, let's say for example, it was deployed and it gave the answer as no, but actually it was a fraud. What it will do is it will take those input columns and it will again train on itself, just as we humans do. Whenever we see that, okay, this is a mistake that I have performed, what we do is we again see this information, we again try to summarize it, memorize it, and we try to perform that task again. Now, what will happen is whenever the AI system is encountered with such information again, it will output it yes. And this accuracy that was 95% will start to increase. And that is what is machine learning in simple words. Machine learning is a subset of AI that will give computer system to learn from data. And that is what I have showed you right now. Computers will slowly and slowly learn from this data. And you'll be asking me, sir, how is computer learning from this data? I'll be teaching you that, don't worry. The key phrase is without being explicitly programmed. Now, we did not go and tell this AI system that whenever the input is coming as this, output yes or else output no. We didn't define a separate if else structure for that, right? What we did was we gave the data to the machine and we told it to learn on that data. And now that machine is performing the task of predicting on its itself. And that is what is machine learning. What is traditional programming? You write rules for every type of condition. You write different rules. But for machine learning, the data itself will reveal those rules. In traditional programming, whenever you program in a traditional way, you define every condition. And you might have been heard this that whenever we are programming, we have to see the edge cases. But in machine learning, this is all done by machine itself. You just have to give it data. It will perform computations on it and it will try to understand what are the edge cases. Input plus rule will give you output. Input plus output will give you rules. If the rule is wrong, that is, whenever you have written, let's say for example, you have written a simple if else condition. If the if else condition is wrong, what you do is you rewrite that. Right? But if in machine learning, if the prediction is wrong, the model will automatically adjust it. Works well for well-defined stable problems, and machine learning is working well for complex and changing data. Now, the concrete example for this is spam detection. You can go through this. I just explained you also the fraud detection. It works in the same exact way. Now, what is the importance of ML in business decision making? You can go through this again. So, the levels that you are seeing is for a specific company. Every company has these levels, and how machine learning can help in that is shown right here. Now, AI, ML, and DL, the hierarchy. AI is the outermost circle. I showed you in that diagram. AI is the outermost circle which will encompass everything. Machine learning sits inside AI. It is a specific approach to AI that is using data and statistical algorithms. I'll be teaching you about these algorithms in the coming months. Now, deep learning sits inside machine learning. It is a specific type of learning that uses multi-layered neural networks. So, how do machine learning and deep learning differ from each other? Is in machine learning, you are using only statistical algorithms. You aren't touching on neural networks right. But in deep learning, you are specifically using these neural networks. Neural networks at the end of the day will be using statistical algorithms. But the approach to using the statistical algorithms is a little bit different. Data science is adjacent to all three. It is not included in AI, nor ML, nor DL, but everything that is AI, ML, or DL will require data, as I've explained to you. AI or ML or DL will require data for its functioning. And this is where data science comes in. Data science is the science of how well structured the data should be so that AI or ML systems shouldn't struggle in learning that. And what do I mean by that is, let's say, for example, today I tell you to learn about AI. What is the first step that you'll do? You'll go on internet and you'll search for a roadmap or how to learn AI. Okay. Now, what is this? This is the data that is present in a structured way. Let's say, for example, if this was not available, any roadmap or any type of these things were not available previously, what would have happened to you? You would have gone to multiple places, searched for the data, collated that data, and then you would have verified from others that, okay, if this data is correct or not, and then recorrected yourself. Did you see this? Majority of your time have been spent in collecting data and cleaning it. That is what is done in data science. Data science will do this task for you. It will collect data, it will clean the data, and it will present the data for AI, ML, and DL. The task of AI, ML, or DL systems is to just learn from this data. So these are some differentiation that is given. And these are some real life examples of AI. That is, how is it used in Amazon recommendation engine? So whenever customers, search for some products, the model will look at your purchase history, how have you been browsing on their website, also your wish list, and then it finds thousands of other customers who have the similar behavior patterns. Then it will check that other customers with similar behavior pattern, what did they want to buy after this? And it is what it will recommend to you afterwards. So these are some examples. You can go through them. I discussed about fraud detection also. Now, let us move to the AI product lifecycle. Why this lifecycle matters? Most courses will jump on AI directly. What is the code? What are the algorithms? What is statistics, etc. But before learning all this, you should understand what is the life cycle of these AI projects. That is, how do we start a AI project? Now, the phase one of the AI project is problem identification. And this is really important. Why? I'll be explaining to you. Let's say, for example, you build a project and you publish it on GitHub or any other collaborative tool that you do. The first thing that the recruiter will ask you about your project is what is the problem you are solving? Now, if you are someone else that is just copying your projects from ChatGPT or GitHub, you'll face some difficulties here. You won't be able to concretely explain what is the problem in here that you have identified. And problem identification is not only limited to thinking about what I have to build. Problem identification is really important because certain problems require you to train model in a certain way. So this is a very important phase in your AI project. And you should spend, I would say, majority of the time on this. That is, what is the business problem you are trying to solve? Where does AI come in the business problem? Majority of the use cases, they are not AI specific. They are program specific. That is, let's say, for example, you have to build a placement predictor for your college. The first thing that you have to build is a way to get the previous placement data in your website. How will you do that? You will do that using APIs and stuff. AI is a small part, or machine learning is a small part of the problem. What does success look like? This is also a really important part. What will you define as success? What will you say that, yes, I have completed my task? Is this the right problem for AI? No, not every problem needs AI. You need to understand this. Not every problem will require AI. Some problems can be solved by simple programming. And wherever AI is not required, you shouldn't try to insert it there. And why am I saying this is, I have explained to you in previous slides, AI requires some computation power, some statistical power in it. Whenever you are integrating AI in your website, you are adding an additional computational overhead. That is, now your particular website will become slow. It is natural because AI will require some time to process the input, right? So, wherever the problem does not require AI, you shouldn't try to insert it there. Here are some examples that are given. The second phase is the data collection phase. You have to identify, gather, and consolidate all data sources. Also, the most important fact about a model. A model is only as good as the data it was trained on. Let's say, for example, the chat GPT, if I would have trained on a very bad data, that is, that data didn't make any sense, the output that it will be giving is also that type of only. That is, it will give us bad output. And in the future classes, around in module 7 or module 8, when we are actually building some ML models, I'll be showing you this hand in hand. That is, whenever we try to insert some garbage data into the model, it is not a magical machine. It won't output some great result. It will only output garbage results only. So that is why I said data science is really important, because that is where you will be learning about how to clean your data, how to structure your data so that ML models will understand what it is. So here are some types of data sources and some key considerations that you should take into mind. These are some theoretical points that you can go through them. The data collection tab. Teams frequently underestimate how long data collection takes. Identifying sources, getting access approvals, extracting data, negotiating with data owners. So in real world AI systems, whenever you are, working on a real AI project, I would say data collection will take 60 to 80% of your total project time. Problem identification will take 10 to 15%. This will take 60 to 80% of your time. So you should always confer a very high importance on data collection. Also on data cleaning too, because according to your problem, you will define what type of AI you need. And according to the type of AI that you need, your data collection strategy will differ. Phase three is the model development. In here, you will actually develop the model. First, you have prepared your data in the second module. Then you select the algorithm. What type of algorithm do you need? Then you do training and hyperparameter tuning. I won't be discussing this right now because we will be coming to this topic in the further classes. Then is the model evaluation. You have trained your model, you have done everything. Now you have to evaluate how good your model is. And this is what is done in this phase. That is, measure how well the model performs on unseen data. Because the data that has been fed to this model is the seen data. It has seen this data, it has seen the output, and it has learned on that output. Now, what we'll be doing is we'll be giving some completely new piece of information, an information which it hasn't been trained on. And AI will be giving output on this. This will tell us what is the accuracy, that is percentage of predictions that were correct, the precision of all predictor measures, how many were actually positive, okay, and recall score, reference score, etc. Again, these are some important concepts that we'll be learning in the further classes. Now, overfitting and underfitting. पानी पीना पड़ेगा इतना कंटिन्यू डोसा बनाना चालू करो. Okay. So this is what are the different types of scores. Now overfitting and underfitting. What do you mean by these terms? And these are really important terms you should understand before training any AI model. Let's say, for example, you have trained a model, okay? AI model. And when you were training this model, it is giving an accuracy of 100%. You'll be really happy. You'll be saying that, sir, I have made an AI model that is giving me correct answer for all the times. Whatever input I give, it will always give me correct answers. Now, what you do is you show it unseen data. The data it wasn't trained on. You pass this data to this AI model, and now you find that the accuracy has fallen to 30%. You will be worried. You'll be saying that, sir, something is wrong with this unseen data because previously our AI model was giving an output of 100%. This is what we call as overfitting. Overfitting. And if a real world example I have to give is, I'll be giving you an example of ourselves only. Let's say, for example, you are preparing for your science test. The time is really less, and what you do is you try to memorize or rote learn all the answers. You rote learn all the answers. You don't know what is the fundamentals behind it. You don't know why sodium explodes. You don't know why sodium chloride mix and form some component. You have only rote learned the entire topic. Now, during exams, let's say I present you a question that was not present in your books. Here is where you will fail because you have rote learned everything. You don't know what are the fundamentals of that topic, right? And here is where you will try to, make up something or write some answers because you don't know the in-depth knowledge about it. And that is what has been done by this AI model. AI model has rote learned everything. That is, it has learned that yes, for a particular set of inputs, this alone will be the output. It is working well for the data it has been shown. But whenever we show it some unseen data, it will fail because it has rote learned everything. It will see this unseen data and it will be like, oh, I don't know anything about it. I haven't studied about it yet. And it will give us an accuracy of as low as 30%. Now, how do we actually control these? Because a question might be arising in your mind is, sir, if we pass data to AI models, they will rote learn after all, right? No. In here, the concept of probability comes in, and I'll be teaching you about this in the next classes. So don't worry about it. What is underfitting? The model is too simple to capture real patterns in the data. Now, in the same case, let's say, for example, you train an AI model, and on the training data itself, where it should have performed well, it is giving you an accuracy of 30%. This is called as underfitting. It is just as gambling on something. That is, let's say, for example, I tell you what is a coin toss, and you say that it will come as head. You have gambled upon it, right? That is what is being done by AI model also. It doesn't know what is the pattern of the data. It doesn't know what is actually happening inside that data. It is just giving you some gambled predictions about it. And that is what we call as underfitting. And this is really bad. Okay. And the phase five is deployment. After checking everything, after checking whether it is, AI model is learned extremely well. There is no case of overfitting or underfitting. You deploy this model. After deployment, you package that model using TensorFlow saved model. You build an API. So at the end of the day, the end user, let's say for example, you were an AI scientist and you gave this AI model to your software development team. Now, this software development team does not know how to actually interact with AI, how to actually perform computations with AI, right? What you'll be doing is you'll be just building a simple API that is a REST API. Its simple task is to take an input and give an output. This is the language that the software developers understand, and this is how we'll be actually passing our AI models. I'll be teaching you how to actually you'll have to do integration. You'll be doing testing, deploying the model to a subset of users first to validate real world performance. Whenever you try to build any AI model, it isn't deployed to 100% of users. What is done is we take a subset of users, let's say 2 or 3% of users, and we show this AI model to them first and ask them what is the output, is the output correct or not. Based on the feedback, we may retrain our model and then we actually deploy the model on our production side. The infrastructure that is needed, model monitoring, the often forgotten step. Deployment is not the end. So let's say, for example, I have now deployed this model, right? We have deployed this model. In the year 2023. And let's say, for example, it is a fraud detection model. Now it is deployed, it is detecting frauds. At the time of deployment, the accuracy was around 98%. It was working really well. Now, if you are like a normal individual and you are not monitoring, you will not notice that as the year comes to 2025, the accuracy has suddenly dropped to 72%. Now you will be saying that, sir, we have done the training so well, it was working well in 2023. What has happened in 2025? Well, as you are evolving, as the years are evolving, the terms or the methodologies of fraud has also evolved, right? Now different types of inputs are there, different types of methods are there for a fraud detection, and now they are also bypassing our AI models. They have got to know that yes, AI will understand certain type of things, and if we change our methodologies, AI will not be able to detect us. And if you wouldn't have set up this monitoring, you wouldn't have noticed this. So in real world scenario, what happens is we continuously monitor this accuracy. If it follows beyond a certain threshold, let's say for example 95%, we again do the perform our accuracy and all. We again deploy it and we try to keep this accuracy at 98 or 99%. Whenever it falls to around a certain threshold, that is 95%, we take the data, retrain our model, and we deploy that model again. So that in future scenarios, that is, let's say 2 or 3 years down the line, our AI model is performing perfectly. That is the retrain cycle. Production ML models do not stay static. They require regular retraining with fresh data. So this is a quick reference card that I have built. You can go through this. In the coming classes, we'll be learning about the actual statistical models that are behind this AI. That is the fundamental mathematics that is used for these AI models, probability, mean, median, mode, etc. Thank you.